All right. This is going to be an extension of the alternative hypothesis. And basically, this is what we've done. We fired the ball at 0 degrees. And then we fired the ball at 20. And then we fired it at 30. Okay, that's way too, the angle is way too big, but the idea is we fired it at 20, and then we fired it at 30, then we fired it at 45, and then we fired it at 90. So we interpolated all of our data from 0 on up to 45. What we want to do now is we want to interpolate our data on out to 90 degrees. So let's look at this by going back to Excel, looking at Dropbox, and going into our folder where everything is nice and neatly organized, term 6, 2014. And we're going to 2015, and we're going to go to, you see that I have interpolating to 90 degrees here, but that's not where I want you to go. I want you to go to in-class interpolation or alternative hypothesis, and this is what we're going to do. Now, I'll most likely have to go back to that other sheet to acquire some data, but we want to take this on over to 90 degrees. Right now, we're at 45 degrees, so we're going to take this on out to 90. The primary thing that we're going to need are the increments for the height, and so I need the height in order to do this. Let me see if I have it over here. Nope, 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 I don't. So I don't need that. Let me just delete that sheet. No, I can't, so I won't delete it yet, but we have alternative here. So I am going to duplicate this. So this should be in your alternative folder. And make sure you have a folder for your interpolating to 90 degrees. So we're going to go to 90 degrees. Save that right there. So we know where this information is located. Now, again, the only thing that we'll need, and we can just start off right here. We can start off with 45, and let's just take this on out to 90. Or better yet, let me go back and let me see if I can find the information in interpolating to 90. So we have our correction here. You don't have this file. This is a file that I worked on before. I just want to acquire some information. Ultimately, we're going to have a graph that looks like this. But what I need is this 23.3. So we measured the height to be 23.3. Okay? So let's go back and let's open up our alternative hypothesis to 90 degrees. And we want to put that 23.3 in here. Okay, so we need to remember where it go. I mean, what it is. So we need to go down to 90. So I'll just fill and drag this down to 90. Let me fill and drag up to just 90 here. And then I want to go over, there it is. I think it's right here. So if it's not, we can always correct it. It's going to be 0.233. And let me just make that orange because we're going to use this to interpolate between 0.189 and 0.233, just like we were doing with the other ones. And we'll just get a complete graph for the entire range of going from 0 to 90 degrees. So let's just drag this down. I'm going to go ahead and fill. Drag down. Okay. And then I want to do the same thing here. Yep, I'll just do the same thing here. Fill, drag it down to 90. All right. And we're just going to copy that over. And then I'm going to do the same thing here. Fill. Drag down to 90. fill, drag down to 90 here. And notice that the velocity in the y direction, all of your initial velocity is now in the y direction, which is what you want to see. Okay. And then we have our increments here. So now it's time for us to increment between this value and this value. So let's do that. We've developed increments all the way up here. And so let's do the same thing here. Remember that this is just going to be equal to the parenthetical statement, or the grouping, let me just say the grouping of 0.233 minus 0.189 divided by, how many cells is that? 45 to 45, so that should be, I'm going to say 45. I think it's always like one more than 45. So it needs to be 46 for whatever reason. And so I'm going to go ahead and say equals to the above cell. And I need to fill and drag this one down right to that location. And now this needs to be equal to 0.189 plus the increment return. All right, so I'm going to fill that and drag this one down to right above 23. So it shouldn't go above 23 dash 3. It's at 23, well, not dash 3, but 0.233. It's now 0.231. So one more should take it on up. And I believe that this is just a calculation. So I'm going to fill and drag this calculation down. To that location. We're going to do the same thing with our angles here, because this is where our graph is coming from. And we're just letting Excel do the work for us, incrementing the numbers out to 90. Then we have our prediction, our range prediction here. It's just a calculation. So it's going to calculate all the way out to this very, very small number, this 1.31 e negative 16. That's 0. So eventually it's going to get to the point where it doesn't go anywhere in the x direction. Okay? Even though it's a number, it's effectively 0 for our scale, the size upon which we live. Now we can take our graph here and we can drag down to include all of these data points. So actually, let me drag back up. And I wish you guys could see this in real time, but you see the graph here. What we're going to do is we're going to move from 45 here. We're going to go from 45, which is where it stops. We're going to take this on out to 90. That's what we're doing. And our equation for the line will probably not change here, but this is what we have. So you see this linear line here? This linear line is trying to fit everything into this, so it's actually incorrect. I'm wondering, can I take it out? I'm not sure. Nope, not that one. Nope. Well, it took off the, let me see, trend line. Can I remove the linear? I want none. Okay. And now let's see if I can put a trend line on here and make it, I don't see any options to really make this. See, it just does a linear fit, okay? The deal is what you need to do now is you need to take this to Microsoft Excel on your desktop. And so that's what I'll do in the next video.